Precision is the quality of being sharply or clearly defined, or how closely the indicated value matches the true value. The precision of a measurement device is in part a function of its resolution, which is the smallest graduation into which an instrument is divided. For example, a rule marked in 1/2 millimeters has a higher resolution and thus can be more precise than a rule marked in millimeters. Accuracy is defined as the degree to which an indicated value conforms to an acceptable standard value. For example, two tape measures may both have the same resolution or graduation, in this case millimeters. However, if these tape measures are not equally accurate, their differences become more noticeable at greater lengths. Each graduation on the stationary bar represents 1 millimeter. The vernier plate essentially divides 1 millimeter into 50 units, with each graduation representing 2/100ths of a millimeter. These 50 units represent exactly the same distance as 49 units on the stationary bar. Because of this minute difference, when a measurement is taken, only one graduation on the plate will exactly coincide with a graduation on the stationary bar. This intersection is where the fractional portion of a vernier caliper measurement is read. To read the vernier caliper, first indicate the number of millimeters that are between the 0 on the stationary bar and the 0 on the vernier plate. Then locate where the graduation on the vernier plate exactly coincides with the graduation on the stationary bar, and reading off of the vernier plate, note that number's value in hundredths of a millimeter. Add the vernier plate reading to the number of millimeters counted on the stationary bar for the final measurement. Micrometers are produced in various precisions, both in metric and English units. In every case, it is the thread pitch of the spindle screw that makes each type different. The thread pitch is the distance between two adjacent thread crests. In this example, the thread pitch of the micrometer spindle screw is precisely 1/2 millimeter. Each revolution of the thimble moves the micrometer spindle 1/2 millimeter. The micrometer has a reading line on the sleeve. The vertical graduations on the top of the reading line each represent a single millimeter. The vertical graduations below the reading line indicate 1/2 millimeters. The beveled edge of the thimble is graduated into 50 divisions. Since a single revolution of the thimble moves the spindle 1/2 millimeter, each thimble graduation equals 1/50th of 1/2 millimeter, or 1/100th of a millimeter. The thimble is rotated and the spindle advanced until the feature is held between the anvil and the spindle face. To read this micrometer, add the number of millimeters and 1/2 millimeters visible on the sleeve to the number of hundredths of a millimeter indicated by the thimble graduation, which coincides with the reading line on the micrometer sleeve.